Aryabhat Center for Theoretical Physics. This is second lecture on this lecture series linear algebra. In this lecture I am going to explain column vector and few operation on the vector. What is column vector? Suppose there is a vector which is related to or which is belong to vector space Rn. Rn, there is a vector u which belongs to this vector space. We can write component of this vector as in the column form 1, 2, 5, minus 3, 1.245. These are the column vectors. So we can write vector as in the column form. So this is called column vector. Now we can perform some some operation on the vector, on the two vectors. Suppose two vector u and v which belong to the vector space Rn, and components of u is x1 to xn and v is equal to y1 to yn. So we can add these two vectors. Sum of two vectors u and v is equal to x1 plus y1, x2 plus y2, so on, xn plus yn. U plus v two vectors, and we can add their components, so we will get the sum of two vectors. Again we can multiply a scalar quantity with any vector and we will get that number times the component of the vector. So if k number multiplied by the vector u, so we have to multiply the number k with each of the components, kx1, kx2, kx3 dot kxn. So we will get this. And suppose u or um are the vectors in the Rn space and k to km scalar quantity belongs to the R real number R space. Then v is equal to k1 u1 plus k2 u2 dot km um. We can say that there is a vector v, another vector v, which is the linear combination of this vector u1 dot um. It means we can write any vector v in the linear combination of another vectors. Linear combination of another vector. So we can use one vector to write the linear combination of another vector. This is the beauty of linear algebra. And again, if we add 0 with any vector u, we will get the same vector. So these are the few operations on the vector. Now here is the theorem related to vectors. U, V, and W belongs to the vector space Rn. K and K dash, which is the number, belong to the real number space R. Then we can say that U plus V plus W is equal to U, V plus W. Again U plus 0 is equal to U, U plus minus U is equal to 0, U plus V is equal to V plus U, and K, scalar quantity K multiplied with summation of u plus v is equal to ku plus kv. Two number k dash, which is addition of k dash will be multiplied by another vector v, another vector u, we will get ku plus k dash u. These are the few theorem related to this vector. Again, inner product of two vectors, inner product of any two vectors, u and v two vector belong to the vector space Rn, and suppose u and v both have components a1 dot an and b1 b2 dot bn, then inner product of these two vector u dot v is equal to simply the multiplication of these components a1 b1 plus a2 b2 dot an bn. And if inner product of any two vectors become 0, then we can say that u and v are orthogonal. It means they are perpendicular to each other if their inner products come out to be 0. Now we can use the inner product in this way, solving one problem. U is this much, 1 2 3 4, V is 6k minus 8 2. We have to find the quantity k such that U dot V will be 0. It means inner product will be 0. So U dot V is equal to 6 plus 2k minus 24 plus 8 is equal to 0. Multiplying each component and adding them, and 10 plus 2k is equal to 0 and k is equal to 5. It means if k is 5, then we can say that inner product of these two vector will become 0. Now come to the norm or length of any vector. Norm or length of any vector is simply root of the inner product of the vector with themselves. So root u dot u, norm of vector u, or a1 square plus a2 square dot dot an square. And if inner product of if length of the vector is become 1, we can say that unit vector. Also we can find unit vector to any other vector. This is the unit vector v. We have to find the unit vector of v. So unit vector, any unit vector is equal to vector v divided by length of that vector, v divided by norm of vector v. For vector v is non-zero vector. This way we can find the unit vector, and and also this unit vector will be in the same direction as that of vector v. And process of finding unit vector to any specific vector is called normalizing that vector. So these are the few operations on vector. Suppose u is 1 minus 2 4 5 3 components of the vector u. We have to find the norm of this vector or length of this vector. So length of this vector is 1 square plus minus 2 square 4 square 5 square 3 square. Square of sum of square of all these component, we will get 55 u square. So u length u is root 55. This is the norm of the vector u. Again we have to find unit vector. V is the vector 1 minus 3 4 2 component. Its norm will be root 30, and unit vector which is in the same direction as v will be that vector v divided by its norm. So we will get 1 divided by root 30, minus 3 divided by root 30, 4 divided by root 30, and 2 divided by root 30. This is the unit vector as in the same direction in the v. Now there is a inequality called Schwarz inequality. If any two vector which belongs to the vector space Rn, u and v, there is a theorem which says that dot product of this u and v is smaller than or equal to the product of the norm of these two vector. U dot v is smaller than or equal to the norm of u multiplied by the norm of v. This is called Schwarz inequality. And there is similar called Minkowski inequality which says that u v belongs to vector space Rn such that norm of addition of these two vectors u plus v is smaller than or equal to the addition of norm of individual vector. So u plus v, norm of u plus v is smaller than or equal to norm of u plus norm of v. These are the two inequality related to the vector.